So for your paper two, remember, like I said, you need to know these formulas. So STP is standard temperature and pressure. What is that standard temperature and what is that standard pressure? Because when I say standard temperature and pressure, it means there is a standard temperature and then there is a standard pressure. The standard pressure is this one. It's going to be given at the back of your formula sheet, at the back of your question paper there. Those last pages, you will find this table there. It has the standard pressure and then it also has the standard temperature. So here's the standard temperature is 273 kelvins. Okay, 273 kelvins. I hope that is fine. And then now, whenever we talk about STP, you need to remember that the molar gas volume at STP, which is Vm, is always going to be 22.4 decimeter cubed per mole. You see, you don't have to cram it. It is there. As long as they mentioned standard temperature and pressure, which is STP, you know that Vm is going to be 22.4. So I don't know. I used to 4.3 because sometimes they write it as 4.3. So let's just use 0.4. Now, that is fine. So we do know that Vm is that. What else are we given? We're given that we have 1 decimeter cubed of ammonia. Now, if they say 1 decimeter cubed of ammonia, are you given, you ask yourself, okay, am I given concentration, or am I given volume, or am I given number of moles, or am I given mass, or am I given molar mass? What is it? That 1 decimeter cubed of ammonia. If I say to you, we have 1 decimeter cubed of ammonia, what did I give you? Concentration, volume, temperature, moles, what is it? Anyone? Volume. Perfect. 1 decimeter cubed is volume, because volume in chemistry, we measure it in decimeter cubed. Or speaking of which, sometimes we're given in centimeter cubed and you have to convert to decimeter cubed. But a bit of a story for another day. For now, just for now. So 1 decimeter cubed is the volume for ammonia. Now you need to be able to know that ammonia has a formula NH3. So you go to ammonia there, which is NH3, and realize that, oh, the volume that is given is 1 decimeter cubed. Perfect. That is the volume that is given for ammonia. And that's it. You're only told that this is happening at STP and that you have 1 decimeter cubed of ammonia. So now, the question wanted you to calculate the volume of hydrogen. So we're looking for the volume of hydrogen. But like I told you guys, when you find a question like this, you need to work in moles first. Then you go to the molar ratio. So you convert what you are given to moles, and then after that you use the right formula. Use molar ratio, then use the right formula to get the volume that is needed for hydrogen. So let's start by converting this to number of moles. So remember that since we're given volume, you have to choose between this formula, that and that. So you have 4 formulas here. You have to choose between this one, that, and that one. But the ones that have volume is this one and this one. That's how I can circle them. It's 2 of them that has volume. But this one has concentration. Was I given any concentration there? No, I was not given any concentration. So I'm not going to choose this one, but instead I'm going to choose that one. You see, that's how you identify the formula you're going to use. So we use your N is equals to V over Vm, and I believe that's what Miss Ria said. So the volume is going to be 1, and then the molar volume, your Vm, remember it's this one, which is 22.4. So you write 22.4, and then you use your calculator to get, remember these are the number of moles of ammonia. You need to indicate that I'm dealing with the number of moles of ammonia, right? So what do we get there? So let me copy from some of you here. Yeah, I see that Miss Ria got 0.0446 mole. That's very nice. So it's gonna be 0.0466 mole. Let me see if so I see that Miss Uri also got the same thing, which is very nice. So it is 0.0466 mole. It's either use mole or you write moles, remember, right? So first step done. This is your first step. Done and dusted. That's just oh, it's 446. Oh, thanks. 446 more. Oh, yeah, perfect. That's step number one. You convert the given information to moles. Then step number two, you need to use a molar ratio, right? So your molar ratio is going to be between the compound or the element of which you are given information and then to the one that you're looking for. The question asked us about hydrogen, right? So we know that now we have to say number of moles of hydrogen because this is the one that we want, right? We want the number of moles of hydrogen, then we can get the volume of hydrogen. We always have to start with number of moles. But here we're going to say number of moles of ammonia. You see? Why do we use ammonia? Because that's the one that had information that was given. So you say number of moles of the given is to number of moles of the one that is asked in the question or the one that you are looking for. Okay, so this is called your molar ratio, and that is your step number two. So that is step number two. So let's do that. Remember when we do molar ratio, remember that we focus on these big numbers, these numbers that are the coefficients of the compounds. So for ammonia, it is 2, as you can see there, okay? So we're gonna write 2 there, and then for hydrogen, it is 3, as you can see there. It is 3. So the molar ratio is 2:3. Then you say the one that you calculated for ammonia, remember it was 0.0446. You take it and then you're going to substitute it here. Okay, so you write 0.0446. Then you say is 2. Do you know the number of moles for hydrogen? No, so you call it X. Okay, then you are done with, oh no, you're not done. So you cross multiply after, ne? So when you cross multiply, remember it's 2 times x, it's gonna be 2x, and then 3 times 0.0446. So that is 3 times 0.0446. Then you divide by 2 both sides. Now if you do that, what are you going to have for x? This and that cancel. So your x is going to be, let me check what you guys did there. 0.0669. Yes, nice. Hey guys, we're killing this. 0.0669 moles. You understand? But remember, these are the number of moles for what? For hydrogen. So you conclude that, oh, so therefore the number of moles of hydrogen, it's going to be 0.0669 moles. Perfect. But are you done? No, you're not done. The question wants volume, right? So you then go back again to your formulas. You go back again to your formulas here and say, since they are looking for volume, which formula am I going to use? Now we are on the last step. So here, what we're gonna do here is the last step, which is solving the problem. So now which one is that? Which one is that now? So you have to understand that for hydrogen you have number of moles, right? In the question itself, you are given, you are not given its volume, but you are looking for its volume, right? You are looking for the volume of hydrogen. So which formula are you going to use? I believe you can't use the one with concentration. You have to use that N is equals to V over Vm. You understand? Because you have Vm because it's at STP, and then you are looking for volume, and then you now have the number of moles there. Then you are fine. You are just substituting the number of moles for hydrogen. It's 0,0669. Its volume you don't know, but you know that the molar volume is 22,4. So you cross multiply, and the volume will be 0,0669 multiplied by 22,4. So what is the volume for hydrogen? Please always specify. When I'm marking students in my class, when I used to mark physics, I used to always write this in red with the big capital letters. Specify. It's the volume for what? Of a cat, of a donkey, of a cow, or of hydrogen. Right. So you must specify. So the answer that you then get is 1,5 decimeter cubed. And use the correct unit. Again, unit is important. The correct unit. That's your last step. Good people, in that way you have solved the problem in 3 easy steps. So just to repeat those steps. First of all, use whatever is given to convert it to number of moles, right? You choose the correct formula. And then once you are done doing that, you go to the molar ratio. You say the molar ratio, the number of moles of the one that I got the moles for is to the number of moles of the one that I'm looking for, the one I have to solve in the question. And then after that, you'll be able to get the number of moles of that. Then the last step is to use the correct formula to solve for what is needed in the question. I hope we are happy with that. If there is any question, please do feel free to ask. Let's go to the next question, the last one on this homework. I do want these to be there, so let me just also copy the data sheet, and then so the next question says calculate the mass, right, of sodium. Calculate the mass of sodium that will react with 230 grams of oxygen to form sodium oxide. And you know what? Guess what? You are not given the equation, just like in number 5. And that's why I specifically chose that problem. So I needed to see if you can write the correct equation there. Yeah. I saw stuff. Is anyone who can tell me how do I write this equation? Anyone who can guess the correct equation? Sodium reacting with oxygen to form sodium oxide. Yes? Talk to me. Yeah, let me say it before. Yes, you can say it before it's balanced. You balance by putting a 4 before the sodium. And the 2 here. Right. Very, very nice. Very nice. Indeed, sodium we write it as Na, and then oxygen we do write it as O2, right? So for sodium oxide, how does it become Na2O? Can I ask, ma'am, would it be correct if I were to say NaO2 for sodium oxide? Nice, nice. So, how does it become Na2O instead of NaO2? Mm, mm. Wow, wow, that is great, ma'am. That is very nice. Your teacher is a very good teacher. Yeah, you need to tell him that I said he's a very, very good teacher. So indeed, that is what we do. Ne? So what we should know is that here in group one, you write +1 on your periodic table, you write +2 here, you write +3, and then here it's plus or -4, and then here it's -3, -2, -1, and then 0. So when you need to combine elements, right? This is for when you have to combine elements so that you form different products. For example, I can simply ask you to say, why is water H2O and not hot and not HO2? Right? I can ask you that. Why is it not H2? Why is it not hot, which is HO2, and why is it H2O? So we use this numbering system. So what you do is that you say hydrogen is there, it's +1, and then oxygen, as you can see, it's in this group, right? And it is -2 there. So forget the minus, forget the plus. Don't focus on the symbols. Focus on the fact that this 2 is gonna come down there, the 1 is gonna come down there, as if you're cross multiplying. So the compound becomes H2O. Now this, my friend, if you know this, this means you are a good chemist. Okay? No chemist doesn't know how to form compounds. You need to know how to form compounds. And to avoid saying water is hot. Ne? And then let's say you needed to know lithium oxide. Or let me say hydrogen chloride. So I don't want to use the same thing. So let's say I give you hydrogen chloride. Hydrogen chloride means we're talking about the element hydrogen, and then we're talking about the element chlorine, right? So I have to go and check. Hydrogen is in group 1, which is H1, and then chlorine is in group 17, which has a -1, which is, we can write it as Cl1. The one comes there, the other one comes there. That means hydrogen chloride can be written as H1Cl1. But those ones, we don't write them, okay? We just write HCl. Same as if I write 8, I don't have to write it as 8 to the power of 1. We know the 1 is there. So similarly, I don't have to write H1Cl1. I know that those ones are there. So we just simply call it HCl. I hope that is clear, guys. So for sodium oxide, that means you are dealing with sodium and oxygen, of which sodium is in this group. So we can say Na1, and then oxygen is in this group. We can say O2. The 2 comes down there, the 1 goes there, so you have Na2O. And that's why sodium hydroxide is Na2O and not NO2. Right. Quite beautiful. So if you know that, guys, you are definitely gonna be fine in terms of writing the formulas in cases whereby you are not given the formula. Okay, now let's continue with the question. So then, thank you so much, Ms. Ria, for balancing it. So the balancing part comes after, because you realize that no, man, there are 2 hydrogens here. No, 2 sodium atoms. So you need to balance them, but you can't change this and write 4. Just and write 1, right? Or you can say there are 2 oxygens here, and there is 1 oxygen there. But you can't come and say, I'll just write a 2 there. No, you need to write that 2 here as a coefficient, as a molar ratio. Okay? Then that 2 now affects the sodium. It means there are 4 sodium atoms. 4 sodium atoms. And then how many oxygen atoms? They are 2. Whereas this side you have 2 oxygen atoms, but here you had only 1 before we put the 4. So we put the 4 here so that you also have 4 sodium atoms, and then it's balanced. So that is our grade 9 there, guys. So I hope we are fine with that. Then you have balanced it. Then you answer the question afterwards. When we answer the question now, it says calculate the mass of sodium. Mass of sodium. We need the mass of sodium. That reacts with 230 grams of oxygen. So the oxygen, it is how much? It's 230 grams. This is mass of oxygen. Remember, 230 grams is mass. Ne? You always have to ask yourself, am I given mass? Am I given volume? Am I given moles? Or am I given concentration? So there you are given mass of oxygen. So how do I find the mass of sodium? Before I can even try to do it, I need to first find the number of moles of sodium. That's what we need to get first, right? But to get there, remember, you don't start, with just getting the number of moles. You need to convert the one that is given. You convert it to number of moles using the right formula. Okay, that is step 1. So are you going to use this formula? N is equals to M over capital letter M, or are you going to use this one? Or are you going to use this one? Or are you going to use this one? Well, which one has mass? This one, right? That's the one with mass. So that's the one we use, guys, to convert that mass to number of moles. So we're going to say number of moles is equals to mass over the capital letter M. But it's number of moles of what? It's number of moles of oxygen. So you need to specify that I'm working on number of moles of oxygen, and then it's going to be mass over molar mass. Okay, so what is the mass? Is 230 grams. Now what is the molar mass? Remember that for molar mass now, you need to go to the periodic table. You need to use the periodic table. Why did I remove it? So how do we use the periodic table to get the molar mass? So you go to the periodic table, then you say, since you are working with oxygen, what is the mass for oxygen? Remember, this is the number at the bottom. Remember, is your atomic mass, right? That's the one we use there. So you say the mass of oxygen is 16. So you shall write 16 here. But how many oxygens do you have? You have 2 of them. So you must multiply that 16 by 2, because there are 2 oxygens. That is the molar mass, guys, right? I believe we know how to calculate molar mass. So now, what do we get as the answer there? Let me see if any one of you did it there. Oh yeah, nice. 7,1875 mole, ne? 7,1875 moles. And then once we have this, guys, where do we go to? Is there anyone who still remember? Anyone? The ratio. Perfect. So that means since we got the number of moles of the one that was given, now we need to say molar ratio. The ratio of that one that we calculated is to the ratio of the one that we're looking for, the mass of sodium. That means we're looking for the number of moles of Na first, so that we get its mass. So the molar ratio, look at the numbers. For oxygen, there is no number, ne? which means there is a 1. Okay, if there's no number, it means there is a 1 there all the time. It's not 0. And then sodium, it's 4. Then you take the one that you calculated. Remember, it's for oxygen, right? So you're gonna write it just down here. So you're gonna say 7,1875, and then you say is to x, because for sodium you don't know yet. Then remember, you cross multiply. Okay, so please allow me to finish it this side. So if we cross multiply, I'm going to have x times 1 is x, and then I'm gonna have 4 multiplied by 7,1875. So therefore, what would be our x? That would be 14,375. Okay, nice guys. 14,375 moles, and then the number of moles therefore of sodium becomes what? 14,375 moles. Now that we have number of moles and then we are looking for mass, the formula that is N and M is which one? I believe, guys, remember that it's this one. That's the formula we shall use there. So what is the number of moles for that sodium? It's 14,375. What is the mass? You do not know the mass of that sodium. We don't have. It's the one we're looking for. What is the molar mass? You go to the periodic table, you check sodium. The molar mass for sodium is what? 23, ne? But I want you to see something there, because we usually make this mistake. I don't know why. For sodium, it's 23 if you check there, ne? But someone might check there and say, but there is a 4. It means I must multiply 23 by 4. No, guys, those numbers that are the molar ratios, ne, they don't multiply the mass. The only ones that multiply is these smaller ones, not these ones. Please don't use these ones to multiply there. So we're simply gonna write 23 because it's 1 sodium. It doesn't have Na2. Yes, you can ask. Okay, ladies first. Oh, 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 that's what you were also saying. Oh, okay. Thank you so much. Thank you so much. I hope you saw it, Miss Ria, that it should be for sodium. So I think you calculated for NaO, ne? Is it for NaO? No, great. But I'm glad you are the one who pointed it out to me, right? So it's not 14. So how much is it? Can you please give to me? 28,75. 28,75, like this. Okay, great. So that would be 28,75. Now that is great. So that means we also need to fix here and put it as 28,75. And therefore now the mass is going to be 23. Now we cross multiply, right? So it's now 23 multiplied by 28,75. So what do we get for the mass of sodium, guys? $661,000 0.25. Great. So that is the mass of sodium there. Is it fine? Is it clear, guys? If you understand those three steps fully, guys, can you please, put a thumbs up there? And then if you have a question, you can just ask me now. Or as they say in a marriage, or forever hold your peace. Mr. Tab, are you there? Hey, man. Are you there, Mr. Tab? Um, great, great. Nice to have you, Mr. Kevin. Long time, man. Long time. Great, 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 great. Um, so that is what we do, guys. And then I believe if you understand that, if you have a good grasp of that, then trust me, in chemistry, especially this term, you're not gonna have a problem. So we just gonna look at a few more problems on this, so that you can keep practicing it. Before they introduce those crazy stuff such as about limiting reagents in term 3. I need you to master this section first. So it's all about making sure that whatever is given, you convert it to number of moles, then you use a molar ratio, then after that you answer the question, meaning you get the one that they were looking for. So let me see a question from one of these past papers. Yeah, here's a nice question here. Here's a nice question here. Let us prepare. Wait. Yeah, here's a nice question here. And here we go. Right. And quite interesting enough, ne? Quite interesting enough. It's the same question I wrote when I was in grade 10 when I wrote this one. Okay, so guys, here's a nice question. Learners take 10 centimeter cubed of a prepared solution and allow it to react completely with that. So to make this a bit easy, because the problem is that it's a bit of a continuation. But don't worry. The question was the number of moles of hydrochloric acid in 5 centimeter cubed of hydrochloric acid if its concentration is 1 mole per decimeter cubed. I don't think this should be a very difficult question. So let's start here on 7.3.1. Do you still remember what is a mole of a substance? Anyone still remember what is a mole of a substance? Because it's a definition that is going to come up. Trust me, that one is always there. And we need to know it. If we can remember from last time, so I'm just going to write it here. If we can remember from the last time, the mole of a substance, we said it is the amount of a substance. Please write it down. The amount of a substance having the same number of particles same number of particles as there are 12 atoms, right, in a 12 gram carbon 12. So like I said last time, a carbon 12, right, that carbon atom, that carbon element, if you have 12 gram of carbon 12 atoms, the atoms that are there are the same ones as the Avogadro's number. So that's why we say that the Avogadro's number represents 1 mole of a substance. So 1 mole represents Avogadro's number, which is 6,02 times 10 to the power 23. Oh, by the way, Avogadro's number should be there in our formula sheet here. Where is it? Ah, they forgot it, shame. But you'll be fine. I think I told you before. So you should be fine. Right. And then 3.2 now. They're asking what type of equation. Now the thing is, in your syllabus, they have removed the type of questions, equations, right? Or yes, I have not seen the type of equations in your ATP for this term. But you should know that we used to do different type of chemical reactions. We have gas forming reactions, we have precipitate forming reactions, we have redox reactions, we have acid base reactions, right? So this one in particular, it's an acid base reaction, and the reason why I need you to understand that it's an acid base reaction is because this term you're gonna work more with calcium carbonate. You're gonna work more with calcium carbonate, and calcium carbonate is a base, you understand? So you have to understand that usually metal carbonates are bases, right? So this is a base here. Carbonate is the CO3 part, okay? And then sodium is the metal. So if you have a metal and a carbonate, it becomes a base. So sodium carbonate is a base. Which other metals can you remember? Remember, metals are usually in group 1 and group 2, excluding hydrogen. So we're talking about lithium carbonate, we're talking about calcium carbonate, understand? Talk about magnesium carbonate. If you have a metal and a carbonate, it becomes a base. So what about this one, HCl? Now the thing is, HCl is a hydrochloric acid. It's an acid, right? It's an acid. This is the acid in your stomach. I'm sure you did digestive system in term 2, and you should have learned about hydrochloric acid, which helps you to digest stuff that you eat in your stomach there. Ne? So if you have a base and an acid, guys, that type of reaction is called an acid-base reaction. You should know that it's an acid-base reaction, and why you should actually know it now is because there will be a time you're gonna do acid-base reactions next year. So it's acid-base reactions when you have acids and then a base. So they usually neutralize each other. Okay, they neutralize each other. And let me tell you something, guys. If this part of chemistry that you're gonna do in term 3, if you don't master it, when you reach term when you go to grade 12, you're gonna struggle a lot with acid-base reactions. And I'm telling you now so that you are aware. Ne? Is there a question, Mr. Kevin? Okay, I know, no problem. No problem. Yeah, so that's what we have there, guys. So now, 7.3.3 says calculate the number of moles of hydrochloric acid in 5 centimeter cubed of hydrochloric acid if its concentration is 1 mole per decimeter cubed. Very, very nice question. Is there anyone who can tell me what would you do then? Anyone who can give it a try? Yes, ma'am. The centimeter cubed. Yes, yeah. Remember, we work with centimeter cubed. work with decimeter cubed. Yeah, we have to convert it. That's that's correct. Can you say it for me, ne? Can you say 5 divided by 1,000 and tell me what you get? So please know, guys, right? That whenever you convert from centimeter cubed to decimeter cubed, you say divide by 1,000. You divide by 1,000, which is the same as saying you multiply by 10 to the power negative 3. So you can choose whether you want to multiply by 10 to the power negative 3 or you want to divide by 1,000. Is it okay? Great. So what is the concentration? The concentration is 1 mole per decimeter cube. Great, from what we were told, right? And then, do we have the number of moles of that HCl? We do not have. I believe it's the one that we're looking for according to the question. And then what is the volume of HCl? Great, so we were given its volume, right? We're given its volume there, which is 5 divided by 1,000, 0.005. And therefore, what do you get for the number of moles of HCl? You cross multiply. Aha. Great. So great. So the number of moles, guys, becomes 0.005 moles. And then you're done with the question. So this was to show you that it doesn't mean that it's always going to be a 3-step procedure. Because what was the use of the 3-step procedure anyway? The procedure was to get the number of moles of the one that was asked. Usually when they ask us, they tell us either its mass or anything else. They don't give us the number of moles of that thing that they are looking for. Here we needed the mass of sodium, but we didn't have its number of moles. So that is why we went through the hassle of converting the other ones that were given to moles and then using molar ratio to eventually get the number of moles of sodium. Then we could use those number of moles in the right formula to get the missing variable. So here we were able to get mass. And then let me show you on the previous one, that was still the same thing. Check. On the previous one, we needed the volume of hydrogen, right? We needed the volume of this hydrogen. But we were not given the moles of that hydrogen. Instead, they just told us to find the volume of that hydrogen. So the thing is, we need to get the moles first, because the moles, as you can remember from the last session, I told you that the mole, if you have the number of moles, you can get anything else. You understand? So that is why here we went through the hassle of converting the volume that was given for this ammonia to moles. Then we use a molar ratio so that eventually we get the number of moles of the hydrogen. And then once you have the number of moles of the hydrogen, now you can choose the right formula, which has number of moles and that variable you are looking for, which is the volume. Then you are able to solve and get the volume of hydrogen. So the main idea of it being a 3-step process is to get the moles of the compound that they are asking of. You understand? We get its moles first, then we can get its volume after, or the concentration after. I hope it's clear. So now, here in this question, what is different in this question? What is different? Now, what is different in this question is that, yes, we still don't have moles for HCl, right? But when we check this formula, we were given the volume and the concentration. So in the question, you were given two things. You were given volume, you were given concentration. So whenever you are given two things about the same thing, you can use those two things to find the third one. Because all of the formulas that you see here, guys, it's always three variables. You understand? Check. It's always three variables. That's how a formula is. It's 1, 2, 3. So if I give you the mass, ne? The molar mass you can get from the periodic table, that means you are able to get the number of moles. Or if I give you the number of moles in the mass, you are still able to get the molar formula using the equation and not using the periodic table. If I give you number of moles in concentration, you can solve for volume. If I give you volume and number of moles, you can solve for concentration. You understand? If I give you number of moles in volume, usually if you have number of moles and the molar volume is from the periodic, is here, right? It's already given. If it's at STP, then you're able to find the volume, right? Similarly, if I give you the number of molecules and the number of moles, you can get, if I give you Avogadro's number, which is always this, right? And then I give you number of moles, you can be able to find the number of particles. The main idea is that if you have two given variables, you can get the other one. So it differs from question to question, right? So in this case, in this question, we're given two variables. We're given concentration, we're given volume. So we simply use them to get the number of moles of hydrogen chloride. But someone might ask me, why are we saying that since we're looking for moles for HCl, ne, can we not use information given by about this guy and then use molar ratio and then get moles of HCl? Definitely we can, provided we have enough information. You understand? So if, for example, let's say I gave you the volume here, that the volume is 10 decimeter cubed as an example, ne? And then I also give you its concentration. If I give you those two things, you can use this formula, C is equals to N over V, and solve for the number of moles of the sodium carbonate. Once you are done doing that, you use the molar ratio. You say number of moles of sodium carbonate is to number of moles of HCl. The molar ratio will be 1:2. Then you use the number of moles you know for sodium carbonate, you call this one X. Once you solve for X, it will be the number of moles of HCl. Then you will have answered the question. But the problem with this three-step method is that for sodium carbonate, we were not given two things. We were only given its volume, which they told us that it was 10 centimeter cubed. You see? So 10 centimeter cubed, remember when you convert it, it's going to become 0,001 decimeter cubed. Okay? 0.001 decimeter cubed. But it is not enough to find the moles of HCl using the molar ratio. It is not enough information because you can't use just the volume to get the number of moles. You can't just use this volume to get the number of moles because you need the concentration. You see that? And then what about NaCl? Dololo. Nothing. They didn't say anything about NaCl. What about water? They didn't say anything. What about carbon dioxide? They didn't say anything. So we can basically say we're not given any information to convert to moles and then use a molar ratio to get the moles of HCl in this particular question. That is why in the question itself, they gave you the volume of HCl and the concentration of HCl so that you can find the number of moles. What a mouthful. I hope that we are clear on that, guys. Is there any question? Yes. In this one, The thing is, for this one, they already said according to the following balanced. But it's always nice to no problem. But it's always, useful to check. Let me say that 99% of the times they give you balanced equations, and they give you the equations itself, especially when you're doing math exams. But for tests, especially for term 3 tests, remember that your teachers are the ones who are sitting at school. So you just can never know. Just be prepared to balance if they say according to the following unbalanced, or they just say according to the following chemical equation. Just check if it's balanced first, then you can do everything else after. Is that okay, sir? Okay, perfect. Any other question? Right, that was a lot, eh? Okay, so guys, all the best for tomorrow as you're returning to school.